Hey, good evening, everybody. We will be starting here shortly in about a couple minutes. You should be able to see my screen. If I can just get a couple of people to kind of throw in chat if they do see my screen and if they hear me okay, that'd be great. You should see a slide with Severe Weather Preparedness 101. We'll get started here shortly after that. Looks like we got about another minute or two till the 6:30 mark here. We'll do a couple more minutes here, an extra minute or two to let some more people file in. Looks like still people filing in here. 1 minute mark. All right, we're about a minute or two past the 6:30 mark here. I'm going to go ahead and get started. We'll have my webcam on here just for the beginning here. Just to introduce myself, I am meteorologist Kyle Perez here at the National Weather Service in Springfield. Today, my co-partner will be Mark Birchfield. He will be on the question and answering section. More to come on that and where you may want to implement your questions as we go through this presentation. But otherwise, thank you for everybody that joined us on this evening. Also a reminder that we will be having this webinar recur once again next Tuesday, April 6th, the same time, 6:30 p.m. So anybody, if you know anybody that was not able to make tonight's presentation, make sure to pass along that there is another opportunity next week as well. So today we will be discussing Severe Weather Preparedness 101. So just to begin here, I wanted to give you a quick insight of how to use the GoToWebinar interface. For anybody that has not used this before, you're able to post questions in the questions section that you should see on the right-hand bar of your GoToWebinar interface. This is where we will be looking at questions and taking questions. There's also a chat section for just general discussion. Lastly, all attendees will be muted throughout the webinar to prevent any background noise as well. So let's discuss a little bit about the National Weather Service. First off, our mission is to provide forecasts and warnings for the protection of life, property, and enhancement of the national economy. While our vision is working to build a weather-ready nation, this means building a community resilience in the face of increasing vulnerability to extreme weather and water events. The National Weather Service, we are only a small part of it here in Springfield. We make up one of 122 National Weather Service forecast offices across the country. And taking a closer look at our area that we serve, known as a County Warning Area, or CWA as we refer to it, we cover 37 counties across the area, 34 counties in portions of southwest, south central, and central Missouri, and 3 counties across portions of far southeast Kansas. So something we always want people to take into account when warnings and any kind of products are being issued is to make sure that they know where they are located on this map. So maybe take a moment, if you have not done so recently, to know where you are located on this map. I have highlighted here the red line denotes the Interstate 44 corridor that runs through portions of Greene County all the way up to Pulaski and Phelps. So just take a moment to maybe show where you would be on this map. So let's dive right in. This first section, we will be discussing the severe weather overview. On average, the Springfield area, Springfield CWA for that matter, sees anywhere from 54 to 63 plus thunderstorm days per year. In addition to that, on average, the annual number of tornadoes is around 45 for the state of Missouri. And on average for the United States, somewhere around 1,200 occur each year in the United States. So that all plays into weather fatalities. What are the leading causes of weather-related fatalities? When we're discussing severe weather, our main focus on this particular graph would be flood, lightning, tornado, and wind. With that being said, the highest number of fatalities from severe weather hazards occurs from flood. However, the highest number of weather fatalities from any weather-related aspect would be heat, with over 103 number of fatalities on average. So that brings us to our first poll question. Mark will be launching that poll for everybody to answer. And so this will be the question that you will see pop up in your browser now with the opportunity to answer. What severe weather hazard results in the highest number of fatalities each year? Is it A, hail, B, flooding, C, tornadoes, or D, wind? I'll give it 20 to 30 seconds for some answers to come in. It's like we're at about 77% of the votes are in at this time. 10 seconds or so here. So it looks like the majority of the people, 80% tab there, voted for flooding as the highest severe weather hazard, and that would be the correct answer. While tornadoes do result in fatalities across the CWA each year, flooding is still the major leader in the weather-related fatalities when it comes to severe weather hazards. So moving on to the next section here, how do we forecast severe weather? So today I'm going to take you through some of the basics of what goes on behind the scenes when forecasting severe weather. This graph here has lots of information on it going on, but you can see that it shows some of the main ingredients that I will be discussing that go into severe weather hazards. Everything from fronts to jet streams to Gulf moisture and warmer air being pushed into there. So what exactly are the ingredients, the 4 different ingredients we look for when assessing the atmosphere for thunderstorms? Number 1 is moisture. The second one is instability. Third, we are looking for a lifting mechanism. And lastly, we are looking for a wind shear. So I'm going to take you through each of those components here over the next couple of slides. First off, the National Weather Service, we work on assessing moisture for thunderstorm development. So when we mention moisture, we're focused on, is there enough moisture available in the atmosphere to support thunderstorms? And we're typically looking at not just at the surface, but all the way through the vertical as well. What does that moisture profile look like? When we're referring to the surface, you typically think about thunderstorm days as being days where it feels very muggy outside. You get your high surface dew points. Generally, when you start pushing dew points greater than 55 degrees, is when you start to get that more muggy air mass feeling, and it almost seems like it's a good day for thunderstorms to occur. And in fact, that is a good ingredient when we're discussing thunderstorm development. The second ingredient is assessing the instability that's present in the atmosphere. You may hear meteorologists every so often discuss CAPE. What exactly is CAPE? Well, you can see here on the left-hand side that it stands for convective available potential energy. So this is a measure of how much instability is present in the atmosphere at any given time. So us here at the National Weather Service and meteorologists alike use this as essentially a tool to measure, based off the values, how unstable the atmosphere is. You can see on this graph on the right-hand image that anywhere around 1,000 to 2,500 CAPE value, we're generally moderately unstable. But once you start to push 2,500 to 3,000, that's when we start to talk about a very unstable atmosphere conducive for thunderstorms and possibly severe weather. The third ingredient that is needed is a source of lift. Lift can come from many different things: differential heating, fronts, cold fronts, warm fronts, even dry lines, which typically occur across portions of Texas where there is much drier air behind a line, essentially making for the dry line. Next, outflow boundaries. That can be from prior convection that comes through during the morning, or an overnight system and leads an outflow boundary, which can be a trigger for thunderstorms to develop along. And lastly, terrain can even be an influencer or a source of lift. The final ingredient that we focus in on is wind shear. Wind shear is the rate at which wind velocities change through the vertical atmosphere. There's 2 different types of wind shear. One is speed and one is direction. Speed wind shear refers to how the speed of winds change through the vertical, while directional shear refers to how the winds change direction through the vertical. Either way, shear supports organized thunderstorm development. You can see on this image on the left-hand side, the left-hand part of this that you can see here with my cursor, that shows a completely upright updraft thunderstorm. So when this happens, essentially it develops and then collapses on itself. This is kind of what we see with pulse thunderstorms during the summertime. Now, if you have a sheared environment, those updrafts are tilted through the vertical, where the rain will fall ahead of the actual updraft. This allows the storm to sustain itself throughout time. So now that we have assessed those 4 ingredients, The next part that goes into our forecasting of severe weather is assessing weather models. There's over 100 models that we look at, and they all have various model solutions as well. And that varies because we have different input and output going into them. As a result, forecasters are able to assess the models based on model agreement and consistency. More recently, over the last decade, the meteorologists at National Weather Service across the country have really been focusing on assessing ensembles and probabilistic output. Ensembles are essentially looking at several different members of a particular model initiated with different conditions. As for probabilistic output, that is more their approach compared to deterministic. So deterministic is just looking at one model solution and one output. Probabilistic is looking at all the various models and just essentially coming up with what are the different probabilities of X occurring or X not occurring. Overall, the use of probabilistic will allow for the National Weather Service to enhance messaging and forecasting potential severe weather over the next several years. That leads us to the second poll question here. Mark will be launching that here shortly. So which of the following ingredients are needed for thunderstorms to develop? See that pop up on your screen there? So that is either A, instability, B, lift, C, moisture, or D, all the above. Give a few more seconds for some more votes to come in on this particular poll. So it looks like the results are in here, and an overwhelming majority got the correct answer here. 98% came in with the right answer for all the above. All these ingredients are needed for thunderstorms to develop. On to the next section, we will be discussing the NWS severe weather products. So the Weather Service has various products. As many of you know that may follow us on our pages or even follow any kind of meteorologist, whether it's broadcast meteorologists, you see them often share the same information that we are disseminating here at the National Weather Service. This is everything from outlooks to watches to warnings. So to begin, a thunderstorm outlook, as an example is drawn here on the left-hand image, is usually several days in advance leading up to the actual event. And it's a heads up and it gives you time to prepare. Honing in more on as the event begins to the day of this event and honing in on the 2 to 6 hours in advance time period, this is when you typically see your watches issue. And the main focus here is to monitor the weather closely as the conditions are now conducive for severe or potentially even tornado, whether the watch is severe thunderstorm or a tornado watch. Lastly, that brings us to the warning stage. Typically, a warning is going to be issued with a 10 to 60 minute advance lead time. And this is for us to actually, when your warning is issued, you want to take action and shelter immediately. So when looking at the outlook stage, the Storm Prediction Center issues the outlooks for the National Weather Service. There's 6 different categories on the outlooks. The first stage, starting from left to right, is the thunderstorm stage. This is when no severe thunderstorms are expected. But as always, with any kind of thunderstorms, lightning and flooding threat can still exist. As we build on this, we build into the 5 different categories or tiers of outlooks. One, denoted by the dark green color there, is marginal outlook, where generally isolated to severe thunderstorms are possible. More or less in this scenario, we typically see some strong thunderstorms, with a few becoming severe. The second category is slight. This is when there's more scattered severe storms possible. Generally, they're going to be shorter lived and not very widespread, but you can definitely not rule out a few intense storms. The third category is enhanced. The better way to maybe look at this as far as wording is that the enhanced here is essentially an enhanced slight. So this is saying that numerous severe storms are possible, and they're going to be more persistent and somewhat widespread with a few intense likely at this point. Now onto the more significant categories, as some of you may have noticed over the past couple of days or past couple of weeks across portions of the southeast United States, is a moderate risk or a high risk. A moderate refers to widespread severe storms being likely, some of these being very long-lived, widespread, and intense, while high risk, which is rarely issued, despite there actually being two already this year in 2021 across portions of the southeast United States, is for concerns of widespread severe storms being expected, with very much of those being long-lived, very widespread, and particularly intense. Now focusing in more on the watches and warning phase. For a watch, the main thing we want you to be focused on is being prepared. Compare that to a warning, that's when you need to take action. As I mentioned briefly on the slide a few slides ago, a watch refers to conditions being favorable, and we want you to make sure that you have ways to receive weather warnings at this point and continue to check the forecast for updates, have a shelter plan, and remain weather ready. When a warning is issued, this means that potential danger is imminent. Take shelter indoors immediately, and even if driving, find the nearest shelter. And also continue to always check the forecast or updates and remain weather ready when a warning is issued. So now that I have shown you what actions are best taken for watches versus warnings, I'm going to discuss the different criteria for different severe warnings. First, that being a severe thunderstorm warning. At the National Weather Service, we issue severe thunderstorm warnings when winds are expected to be greater than or equal to 58 miles per hour, or hail greater than or equal to 1 inch in diameter. A tornado warning is issued when a tornado is happening or about to occur. Typically, for our tornado warnings, you will find in the tags of the tornado warning that they are either radar detected, radar confirmed, or they're actually reported on the ground. Lastly is a flash flood warning. This is usually occurs when there's intense flooding of different counties, communities, streams, based off the high peak of rate flow of water. And flash floods may result from different things such as torrential downpours and even dam breaks or ice jams, more or less across the Ozarks region. We're generally concerned about torrential downpours resulting in flash flooding across the region. So how do we issue these warnings? You can see this image here on the right-hand side kind of gives you an idea of what it looks like to be on the forecasting desk issuing warnings at the National Weather Service. We use a program called FormGen, and essentially we draw a polygon based on various factors such as storm speed, movement, development, and all sorts of other various factors in the environment that we take into account. And typically these warnings are disseminated through various sources such as the broadcast media and weather radio. So building a little more on that right-hand image, you can see an example of severe thunderstorm warning that is being drawn up. For this particular example, you choose the warning type, choose the storm type, is it one storm or is it a line of storms? You track and draw the warning box, then you set the length of time for the warning, and then building on that further, you select the basis for the issuing the warning. Lastly, you select the particular hazards that are expected and their appropriate call to action statements. This product is then disseminated by the National Weather Service. That brings us to poll question number 3. You'll see the question appear on your screen shortly for you to answer. The question will be, which of the following actions should be taken if a tornado warning is issued for your location? There's only one answer here. I know some of you may be familiar with one of these particular answers. So take a look at those answers. There's A, take shelter indoors immediately. B, go for a drive. C, walk the dog. Or D, cut the grass. And that is the particular example I'm referring to. Where you may have seen a photo of a man, I believe it was in Nebraska, that was cutting his grass with a tornado in the background. About another 10 seconds for people to get their answers in. Thanks, Teresa. I see that her post that she just added into the question section there. It's definitely one that us meteorologists have to refrain from. She mentioned to go out and take pictures. So once again, it looks like the overwhelming majority selected the right answer there, to take shelters indoor immediately. Tornado warning does mean that you are under the gun, and there's particularly no safe way of going about it as far as waiting for it to be on top of you. Particularly that could be very dangerous and too late in many scenarios, as oftentimes tornadoes can be rain wrapped in nature, so they can definitely be dangerous, and that's why we really want you to just take shelter indoors immediately when tornado warning is issued. The next section here, we'll be focusing on identifying different storm types. Before we delve into the different storm types, the National Weather Service here, we have a radar that we use to look at the different thunderstorms. So what does the radar do? Well, it sends an outbound pulse of energy that hits the thunderstorm. And after it hits that thunderstorm, the energy is reflected back to the radar. And voila, there it is. We are able to see that particular thunderstorms on radar and how they appear. Furthermore, we also have satellite data. There's many different satellites across outer space that we use. In particular, we use GOES 17 and 16 across the United States to do weather surveillance for the area. And there's a particular example of how that may appear looking at the wide outlook of portions of South America and North America. So using the satellite and radar detection, we are able to better identify different storm types and focus in more on those. So the four different storm types that I've been discussing here today are single cell or pulse thunderstorm, multi-cells, squall lines, and supercells. So your single cells generally going to look like this animation here. A couple single cells jumping up here and there. Your multi-cell clusters, as we refer to them, it's generally where your training of thunderstorms may occur as well. Then you have a squall line. This one often appears across portions of the Missouri Ozarks region. And lastly, your famous supercells, ones with the little hooks on the back edge of them. Taking a closer look at each of these different storm types and how to identify them on radar. Your first one is your pulse single cell. Your typical hazards associated with the pulse thunderstorms are going to be hail, generally smaller hail, Well, it can grow in size when you have lots of instability present in the atmosphere during the summer months. Gusty winds can also be associated with this. As I mentioned, when you get your pulse single cells developing, you typically do not have too much for wind shear present. So with that being said, you will get these thunderstorms that quickly grow in size and updrafts high, but then will quickly collapse on themselves. And as that particular storm and updraft collapses on itself, that's where you can get your gusty winds. Generally where you hear the term microburst comes from. It's where you get that wind hitting the ground with a particular cell like that. Next, lightning and heavy downpours, always possible with any kind of thunderstorms. That brings us to multi-cells, the various hazards ranging from hail, gusty winds, lightning, and heavy downpours as well. Typically, these are going to be your messier looking days on radar, as seen on this image on the left-hand side. We can see just different cell clusters across portions of the Missouri Ozarks region. Now on to squall lines. With squall lines, you're going to have various hazards. First, you're going to have smaller hail. Generally, your updrafts are not going to be nearly as high as what you see with the upcoming supercells. Your big focuses, though, are going to be straight line winds and the possibility of shorter lived, generally, almost in every case for squall lines, rain-wrapped tornadoes. And then as with other thunderstorms, lightning, heavy downpours, and flash flooding are concerns as well. So this is image on the left-hand side. You can see a particular squall line moving through portions of southwest Missouri, with my cursor here representing where we are at here in Springfield and our radar. You can see that this particular squall line was tracking across portions of southwest Missouri, everywhere from ranging from Branson up towards Ava, into portions of northern Wright County and all the way into portions of central Missouri. Squall lines can typically be very long in nature, as far as extending anywhere from portions of Missouri all the way down into Arkansas and even further than that. So they can stretch several miles, several miles long, pushing across portions of the United States. And more so than anything, you may hear that they're more commonly associated with bow echoes. You can see in this particular image here of reflectivity on the radar that you can kind of see that there's a bowing structure. When we're discussing bow echoes, that's when we're discussing squall lines. And then that leads us to the last storm type here, which is supercells. Your supercells are going to have various hazards ranging from large hail. This is where you're really going to get your very dangerous and damaging hail. Supercells, you know, have been known to produce hail across the Missouri Ozarks, anywhere from baseball to softball at times. There was actually an event in mid-March of last year where we actually got reports of softball-sized hail across Texas County in south central Missouri. They can also produce straight line winds and long track tornadoes. Portions of southeast United States actually saw this just a couple days ago, with a bunch of supercells developing in very long tracked and potentially violent and dangerous tornadoes occurring. And lastly, heavy downpours, flash flooding, and lightning, as mentioned, with all various thunderstorm types. So that leads us to poll question number 4. I'm gonna test you guys' ability here as far as look at storm types. Which of the following is typically linear oriented in appearance and is associated with bow echoes? A, supercell, B, squall line, C, multicell, or D, pulse? About another 10 seconds here, some more answers to come in. Alrighty. It looks like the majority answers that came in, 91%, was for school line. That is, in fact, the right answer. There was a couple votes, it looks like, for supercell as well. We really want you to focus in on bow echoes and linear oriented back in there. It's identifying school lines. So now that we have identified the different storm types, let's take a closer look at some of the different storm features that are present. We will take a look at shelf clouds, wall clouds, funnel clouds, and lastly, tornadoes. So how to identify first is a shelf cloud. Play this video here on the right-hand side. This is a video shot from looking east towards, or looking west, sorry, towards the St. Louis side. And you can see that there is what appears to be a lowering on the leading edge of the rain-cooled air. So typically you're going to see that feature expand across much of the horizon. While this particular feature can look very nasty in nature, it is not typically associated with tornadoes, but it's actually going to be associated with very gusty winds. So that is actually showing you where your particular gust front is, and as a result, potentially dangerous gusty winds. So I'll play that through one more time. See how that shelf-looking feature moves through the St. Louis area in this particular video. And that is where your gusty wind is going to occur. Next, you have a wall cloud. This video here. That bigger, so I can see that. You actually see in this particular video, this is a wall cloud. This is a isolated lowering area of the particular thunderstorm that is going to be persistently rotating. And when it's rotating counterclockwise, that is where we are particularly concerned, because that is going to be associated with the area of focus for potential tornadic development that we'll take a closer look at tornadoes later on in the next couple of slides. So having a wall cloud does not necessarily mean that a tornado will always form, though, but it does denote the area that a large upward vertical motion is occurring in the updraft. As a result, that is an area of concern for potential tornadic development. The next storm feature that we'll discuss is a funnel cloud. Funnel cloud is a rotating funnel-shaped cloud extending downward, but it's not going to be in contact with the ground. And we want to make sure that when identifying a funnel cloud, that it is rotating at the base of the thunderstorm cloud or the updraft, and is an area of upward motion, and it's persistent with time. Typically, it looks like a little pendant shaped that would be extending from the base of the thunderstorm, or potentially from the wall cloud as well. I'll play that video through here on full screen one more time. You can see how that is attached to the base of the thunderstorm. And continues to rotate, but it's not in contact with the ground quite yet. Lastly, that leads us to tornadoes. Here's a picture on the right-hand side of a tornado. running across the plains region. A tornado is defined by a violently rotating column of air extending from a thunderstorm to the ground. Your precursors to a tornado occurring are typically going to be in the area of the rotating wall cloud, and also if there's the presence of a funnel cloud, as mentioned in the previous two slides. As with the funnel cloud, it must be attached to the cloud base, but differing from the funnel cloud and what makes it a tornado is that it is in fact in contact with the ground. So this is visually, you want to see debris being lifted. While you may not see the entire condensation funnel of a tornado being in contact with the ground, if there is in fact debris being lifted, that means that the actual air is being in contact with the ground before the actual condensation funnel is in contact with the ground. And lastly, note to take into account when looking at different storm features is that cloud movement does not necessarily mean rotation. So here's two different videos. We'll play this one on the left. Just want to show two different videos here of what may be misleading when it comes to looking at tornadoes, or the potential for tornadoes, that is. So you can see on this particular video, you're getting some good lighting there. And while it might appear like a tornado at this given time, it is in fact actually not rotating. And this is actually what we refer to as a rain shaft occurring. The rain is actually falling through the sky there, you can see it. So it's not an area of rotation and there's no debris being lifted. Here's the second example. What could be misleading when it comes to looking at and identifying a potential tornado. We refer to these more or less as scuds, scud clouds that go through, and essentially they're just scary looking clouds, with condensation or clouds essentially occurring at lower levels there. But as you can notice in this video, none of that is rotating, and it's actually not in contact with the particular cloud base. So while maybe appearing to be scary, this is in fact not a tornado in this particular example. That brings us to poll question number 5 here. This will appear on the screen shortly for you to answer. Which of the following features must be present to be considered a tornado? A, attached to the cloud base. B, in contact with the ground with debris lofted. C, violently rotating. Or D, all of the above. We can actually take that question there, Mark, that just came in from what is the difference between a wall cloud and funnel cloud. So as briefly mentioned on the previous slides there, you can see that wall cloud was more or less the larger area, so to say, from the thunderstorm of a rotating column of air, while the actual funnel cloud is going to be a little pendant that comes down from that wall cloud. So it looks like the majority of the answers at 85% selected all of the above. Full question number 5 here. And that would be the correct answer. So for a particular storm to confirm that it is in fact a tornado, you want it to be attached to the cloud base, in contact with the ground with debris being lofted, and violently rotating. Now on to severe weather safety and information. Building on all of this stuff that has been discussed in previous slides, from watches to warnings, to how to identify different storm types and features. Let's discuss more about receiving all that information, making sure you have multiple ways to receive that information as well. One example, great resource to check out would be weather.gov/Springfield. Check out there's various aspects that you can see on our websites there. Click and point forecast that you can see here. We have weather stories on this bottom tab. You can even look at all of these different tabs, from current hazards to rivers and lakes, climate and past weather. Lots of different areas to explore there on that graph or on that website. Also, make sure to follow us on social media for receiving information, whether it's Facebook, Twitter, and even YouTube as well, as we be doing more YouTube briefings when it allows for high impact potential events. Another good tool to keep in mind in assessing severe weather information is the hazardous weather outlook, HWO. This is more or less a planning tool that details information over the next 7 days. And there's a graphic aspect to this, and typically it's going to give you the most updated, latest information as it comes in throughout the day and multiple times a day. So here's an example, taking a look at the HWO graphics and what it would look like. You can see there's going to be different little chiclets lit up in different colors here. And clicking on individual one there, you'll be able to take a look at what the threat is for that given day, anywhere from limited, elevated, significant, to potentially even extreme. So that brings us to preparedness. 3 steps to preparedness that we really want you to focus in on. Step 1 being make a plan. Step 2, make sure to build an emergency supply kit and have that in a handy, accessible location. And lastly, step 3 is being informed and making sure you have multiple ways to receive warnings. Don't rely necessarily on just one resource. For example, the outdoor sirens, those are meant to be heard outside. And there's some areas that are very restricted to actually hearing outdoor sirens. Other areas to receive warnings include local TV and radio, NOAA weather radio, various sources on the internet. And then another way to directly bring a warning to your phone is through the wireless emergency alerts, WEA. As for tornado and shelter guidelines, as recommended by FEMA, this is a great graphic really that encompasses what are your worst and bad options when it comes to sheltering from tornadoes, what are some of the best options. So things we really want people to avoid when a tornado warning or when tornadoes are possible in the area. And that's why it's key to make a plan ahead for these particular things, especially when it comes to sheltering. We really want to make sure that, if at all possible, avoid being in a mobile home or vehicle or underneath the highway of the overpass. Other areas that we really want you to avoid are large open rooms, such as like gymnasiums at schools or manufactured housing. So that brings us to some of the better options of what we really want you to focus in on when planning your sheltering guidelines. The nets includes things like the interior room of a well-constructed home or building or a basement. And even building on that, some of your best options are going to be your storm shelters or FEMA safe rooms. Make sure you know your safe place for a tornado. That's a big part of making a plan and being prepared. Not reacting, but put your actions into fruition when the tornado warning is issued. So that includes your safe place and work of storm shelters and basements to the carrier room, or even if you are not able to access some of those, other options do include things such as shelters that are opened ahead of time when tornado potential is occurring across the Ozarks region. So we want you to make sure to take part and let us know what your safe place is. And the National Weather Service will be running this campaign on April 7th this year. And using your social media accounts such as Facebook or Twitter, use the hashtag SafePlaceSelfie to let us know where your safe place is and share how you be more prepared and resilient towards hazards across the region. So that brings us to poll question number 6. Which step is not part of the 3 steps to preparedness? Is it A, being informed, B, moving away, C, building a kit, or D, making a claim? Looks like we are getting an overwhelming majority with one answer here. And that would be the correct answer. Which one of these is not one of the 3 steps? And that would be moving away. Well, that does, I guess that could actually limit your exposure to particular severe weather hazards here in Ozarks. We do not typically advertise for you to move away to Alaska or such if you want to avoid being part of severe weather here in the Ozarks region. So pulling this all together, as I mentioned in the beginning, we want to build a weather-ready nation. How do we do that? One of the big things that we really want to hone in on is sending us your reports. Reports can save lives, and that is something that we don't take lightly here at the National Weather Service. And more importantly, that reports that come in as the storm is in progress are definitely more valuable than storms that come in hours after. So if you're able to pass along that report, baseball size hail, funnel cloud being reported, that's the kind of information that could really fuel us at the NWS to potentially continue our warnings, or potentially it could even be a factor that goes into triggering a new warning. And more so than anything, it definitely helps our partners, including the broadcast media, that rely on those reports as they're coming in live. So what are the different things we want you to report to us? Well, let's start off with hail. When we're taking a look at hail, we're looking at the diameter of the largest stones. We're typically looking for reports of near severe limits or above. So as I mentioned earlier on, we're looking at severe thunderstorm warning being issued for 1 inch or greater hail. So that is going to be the size of a quarter. So any reports of hail 1 inch or greater. Damaging winds, measured speed. If you have a at-home weather station and you're able to take some sort of measured speed, or damage from damaging winds. Even if it's just limbs down, we'd like to know that. Also include the tree or limb diameter, the tree health. Was this a tree that was already on its way out that got knocked over, or was this a healthy oak that it's been very well established and should not have limbs snapped from, particularly uprooted or snapped. Tornadoes, if you in fact can report that there is a funnel cloud occurring, is there that rotating wall cloud present? Did you come across an area that has potential tornadic damage? These are the things we want you to pass along to us for reporting. And then lastly, with flooding, we want to know are there washed out or flooded roadways, and different rain measurements. And this can really help us with calibrating not only our various sources of looking at rainfall measurements, but also can help with warnings and such. In some cases, the radar can be underestimating on particular rainfall occurring in one area. Say the rainfall is only showing 1 to 2 inches on our radar that occurred, but in fact, you measured 4 to 5 inches across your region, and flooding potential is much higher than we actually anticipated it. Those are things we want to know and for you to pass along to us. So when reporting hail, these are some images here of various reports that we've received over the past couple of years. These are good reports. This is what we're looking for. Whether it's taking out that ruler and showing us that what that size is by measuring it, or comparing it to the objects that we recommend you to compare to. We share graphics often that focus in more on this. And we're typically going to be looking for things of greater quarter, 1 inch or larger. Generally, if pea-sized hail is occurring, generally we already have a pretty good idea that that is in fact occurring. So you don't always need to necessarily report things like pea-sized hail, but once we start getting near that severe limit, that's when we're really concerned as far as what could potentially go into our warnings and downstream warnings. Reporting wind damage, I mentioned things like tree branches, limbs. Are the trees completely uprooted? What size are these trees? Even more so, building on that, if you're able to let us know what type of tree. There's a lot more research going into that across the United States, in particular in the National Weather Service, taking a closer look when we were doing our storm surveys of the different storm type or the different tree types, and how they may hold up differently with winds. And also measured wind speeds, if you're able to get a measured wind speed from a home station, allowing us to maybe compare that to nearby sites as well, to really help out. When reporting a tornado or possible tornado, we want to know, is there rotation? Which way is that rotation? Is it counterclockwise or clockwise? And is that particular area of rotation, in fact, attached to the cloud base? So is there a wall cloud and or a funnel cloud present? Is there debris being kicked up or possibly in contact with the ground? It's very important and timely information. And as I mentioned, those kind of reports are what can save other people's lives and make sure that we are able to issue the most timely warnings possible. Then there's reporting flash flooding. This includes everything from flooded, closed, washed out roadways. Across the Missouri Ozarks region, we have thousands of low water crossings. Unfortunately, each and every year, we see people take the risk to drive through those. And sometimes that can result in fatalities. That's what we're here for. It's trying to avoid that, prevent that with time, and make sure we issue the most timely warnings so that people can be prepared and take the proper actions. And also the rainfall measurements to help us collaborate on, calibrate our radars, a better idea of what is occurring out there. So here are some of the reporting basics when sending in your storm reports to us. We want to know who you are, you from the public, law enforcement, or emergency management. What exactly occurred? When did that occur? You know, give us probably, if you can give us the best time down to the minute, that would be great. If you knew that it occurred at, you look down at your phone and it occurred at 7:16 p.m., that would be very helpful information. And also, where was it? When discussing where was it, generally a city is great for you to include, but if you can pin down your location even more than that, that really helps out in the long run for us when we're taking a look at what may be occurring, potential storm surveys down the line. And we want to make sure that you use the proper terms that are mentioned throughout this presentation, things such as a wall cloud, a funnel cloud, any kind of wording that was mentioned in this presentation would be great for you to share with us if that's what you're seeing occurring at your location. But make sure you do not exaggerate necessarily. In best all case scenario, that is. And we always are wanting to know what is your confidence that what you are seeing that is wall cloud, in fact, funnel cloud or tornado. What things are you seeing that are making you come to this conclusion of rotating? Are you seeing debris being kicked up? Are you seeing power line flashes? That's all great information. One thing I do want to mention here with reporting basics is we do not condone people chasing storms in this particular slide here, but our main focus is on if you are seeing something occurring at your particular location, that's what we want. But we do not want you to go out and find that funnel cloud or that tornado that is left more for very trained people and storm spotters that are able to send us in that information when actually identifying those things as they occur, such as emergency management and law enforcement. So there's different ways to send reports. You can tag us on social media or even call us, Facebook and Twitter at NWS Springfield. And you can also call us at the office at 417-863-8028. You can also send reports through this address here. So there'll be, if anybody wants to take a quick snapshot of that slide, go ahead. And this presentation will be available for recording afterwards, so you can always come back to that if you're interested in sending reports to there. And lastly, there is a phone app called the MPing app that allows you to submit different reports from your exact location. Everything from hail size to wind damage and such. You're able to get those reports ingested to our system real time and take a look at those as well. That leads us to poll question number 7. Which of the following do we want you to report to us? Would that be A, funnel cloud, B, uprooted trees, C, baseball-sized hail, or D, all of the above? It looks like, once again, we have an overwhelming majority that are selecting all of the above, and that would be the correct answer. We want you to report all those different things to us. That brings us to Weather Ready Nation ambassadors. This is a really good opportunity for you to build a partnership and collaboration with the NWS and promote the different Weather Ready Nation messages, such as being storm ready, prepared, really helping to build a resilient community when we're faced with these extreme weather events and water events. And the opportunity to become a Weather Ready Nation ambassador allows you to be an example, whether that is at your business or at your church. This is a really great opportunity to really show, promote others to become weather ready as well. The way you can do that is to follow this web link here, weather.gov/WRN/ambassadors. You can also email me. I am the Weather Ready Nation ambassador focal point here at the National Weather Service in Springfield, and I can always help you out in getting signed up for that. And this includes different things such as Severe Weather Awareness Weeks. We're able to share messages with you guys, to share with your business, with your friends, family. It's a really good opportunity to really pass along the message. Once again, here's different ways to contact us, National Weather Service in Springfield, whether that be through social media, YouTube, our webpage. You can email us and call us as well. Here is my email. File for us. As I mentioned at the start of the presentation, you can email me there at my account, kyle.perez@noaa.gov. And Mark Birchfield as well, the meteorologist here at the National Weather Service in Springfield, with his email account below that. And as mentioned at the start of the presentation, if you maybe missed some parts or wanted to see some parts again, had some more questions to maybe some thoughts that come to mind, we will be doing this presentation again next Tuesday, April 6th at 6:30 p.m. The registration link will be sent out through different social media platforms again. You can actually find that registration link at weather.gov/Springfield on news headlines. And these recordings will be available on our YouTube page shortly after we finish the presentation here today. So that brings us to the conclusion. I will leave it here on this slide here if you want to jot down any of those things. But appreciate everybody that was able to join us this evening. And Mark has been working vigorously here to answer several of you guys' questions that have come in. Definitely want to say thanks to Mark for the help tonight in answering all those questions. And don't feel afraid to reach out to us as well. You actually send questions to our contact email there, the contact.sgf@noaa.gov. Compared to emailing just me or Mark, if you send a question through that account, you can actually, there will always be one of us meteorologists here at the National Weather Service in Springfield looking at the email account and can answer those various questions that you may have. Let's see here. Mark, did you want me to answer that question that just came in from Samuel?
That's fine.
So it looks like Samuel's question there was, can supercells be associated with squall lines? And if so, do they produce strong tornadoes and if they are out by themselves? So that's an interesting question. So what you actually may see from time to time is that we'll advertise, two different modes of storm types potentially to occur. So what you may see is that some supercells may develop out ahead of the actual line itself in the what we refer to as the warm sector, where all that moisture is available, and those kind of develop by themselves and be discrete in nature sometimes. And then as that occurs, you may see a squall line develop along, maybe triggered by the actual frontal boundary. And as that sweeps through, they can actually interact with each other, in which the supercell maybe actually be ingested into the actual squall line. So I hope that kind of answered your question. And there in fact can be multiple storm modes that occur with any given event. And then as far as producing the strong tornadoes, well, it's not out of the question that the supercells by themselves can produce strong tornadoes, and squall lines can also produce strong tornadoes. Now, point to you, anybody to get the idea that squall lines only produce weak or short-lived tornadoes. while it is more common that squall line tornadoes are going to be a little bit shorter lived and generally weaker, there has been many cases where squall line tornadoes are in fact stronger in that EF2, EF3 range, which can be very dangerous. And as mentioned with the sheltering guidelines, when we're talking about squall line tornadoes, one of the worst options when particular tornado warning is issued is to be in your car or a mobile home. And if you have even a weaker, shorter lived tornado, a quick spin up of EF0 to EF1 range, where you have wind speeds of 90 to 100 miles per hour, that could easily be enough to be very dangerous if you are in your car or places such as a mobile home or outdoors. Just give a couple minutes here then for any other questions to come in. Otherwise, I definitely appreciate everybody being on here today and hope we were able to answer some of your questions. As mentioned, this course was geared towards building a severe weather preparedness. So I will hang on the line here about another 2 or 3 more minutes. Also wanted to mention that Mark was able to send out a lot of those great links that I shared with you after the presentation. If you were not able to get those are available, click on the chat section that Mark sent those out through. You can actually click those hyperlinks. That will take you directly to them. Take a closer look at those things such as ways to report severe weather hazards to us here.
It's a good question by Elizabeth. Sheltering.
Let's take a look here. That's it, spell the question.
Yeah. If all your rooms have windows. Elizabeth.
A great question from Elizabeth. If all of your rooms have windows, including your bathroom, and you don't have a basement, would the hallway be the safest place if a tornado warning goes off in the middle of the night? Elizabeth, that's a great question, and that's something that we get a lot asked. That if what's the best place, you have to use the best things that you have, and you use what you got. And if you do have a room, if you have windows in all your rooms, you want to find that central part of your house. So if that is the hallway, then for you, the safest spot for you, then that's what I would use. Just everyone has to kind of and you're doing the right thing because you're thinking about this ahead of time. And so just think about that ahead of time. Is in my situation, what can I use the best to help me? And that's a great choice there, that hallway for your case. Here's a great question for you, Kyle, from Justin. He asks, what does a Weather Ready Nation ambassador allow you to do?
Yeah, so I was going back to the Weather Ready Nation ambassadors slide here. More so than anything, it's that opportunity to have that collaboration with us at NWS and share those messages while being an example. So, for example, we have over 100 ambassadors here across the region, and they have a wide variety of backgrounds as far as who the ambassadors are. For example, one of our ambassadors that actually received recognition as the Weather Ready Nation Ambassador of the Year award, so to say, for us here in the National Weather Service at Springfield last year was KTTS News Radio. And how did they exemplify? What made them stand out? And what makes them a good example as a Weather Ready Nation ambassador? That was everything. They do everything from sharing messages consistently and promoting that severe weather preparedness and safety. It's really just about building that community resilience, so to say, that we continue to bring up with Weather Ready Nation. Being ahead of what's occurring, so to say, not taking, scrambling to take proper action when that tornado warning or such is issued, but being prepared ahead of time. What are the right things to do? What are not the right things to do? How we can better be prepared overall as a nation here in the United States in combating against extreme weather. That just about does it for questions, unless Mark sees any more coming in. If not, we will be signing off here shortly. Reminder to any of those that are still on, if you have any remaining lingering questions, feel free to contact us in these various platforms, please. Or if you would like to discuss stuff from the presentation today with me or Mark, feel free to send us an email as well. Thanks, everybody. We will be ending this call here